अच्छा, तो let's assume we are working on a single qubit state. Okay,
ठीक है।
Q0, ठीक है। इसमें we have a gate, let's say arbitrary gate G1.
ओके।
We have a G2
हम्म,
and a G3. So these things are operator, right? Acting on your quantum state Q0, acting on your quantum state Q0. These are operators.
हाँ।
Those are that changing the state.
हम्म,
So whenever an operator acts on a state, it's written on the side like something like this. Okay, let's say it's a n cross one dimension, n cross one dimension quantum state, n cross one, yeah, or any dimensional state, vector space. Then this thing will be n cross n. Operator will be n cross n, and it will be acting on the state like this. This is operator, or you can say it as a transformation from vector space to vector space. The
सही।
thing I was talking about in the last session. This is your vector space. Okay, so we have something like this. So it's, starting with just one gate. Let's say we have only G1. Okay, so G1 has a matrix. Let's say we call it G1. So how will this thing act? It will be something like this: G1 operator, that matrix, and our Q0, right?
बिल्कुल।
Then this thing, let's call it a chi chi naught. Okay, so we are at a chi naught here. Here the state has been converted to chi naught. Okay, so now let's start with psi naught. Sorry, wait. Start with chi naught on Q0 psi naught. We put a gate G2. Now what will happen? G2 will act on that psi naught. This is your psi naught, and let's say it gives something like psi 1. Okay, and things will go on something like that. So we can see that this thing psi 1 is equal to G2 psi psi naught, and this psi naught can be written as G2 G1 Q naught,
बिल्कुल
right?
सही सही।
So if we see, we had Q naught here, G1 here, and G2 here. The order has been reversed. If you write in a gate state, something like, I said that Y gate can be decomposed as that U1 minus pi by 2, this as a gate. Then on the same qubit you apply something like H gate, then apply your Z gate, then apply then again H gate. Yeah, take it as a square, and then your S gate, right? So I gave you this thing like in gate format. But if we write it in a matrix, like something like this, operator state, it will be something like this will come first. G2 was okay. It will be in reverse. So matrix of S will come here. Let's assume that this thing changes that gate into matrix, matrix representation. Okay. So this will be multiply with this matrix multiplication with H, then Z, then H, and then your U. So the order reversed. Like in gates we write this, but in matrix state we something like this. So if we go with Y, then state let's say your psi naught, then these things will act first, and it will be something like this: S H Z H and your U1, and then the state sign off. Okay. Did it clear it out?
या अब समझ आ गया. अच्छा. Okay.
So let's
ये.
see here. This thing you can write it as G3 something, G3 dot G2 and dot G1. So it's in reverse order. Just remember this. I will teach this same during my lectures of another linear algebra class, in which I will uh, uh, go from vector space to vector space with a transformation, and that is this operator. Okay, so I will teach that also in details. Any more doubt?
नहीं ठीक है ये. हाँ एक और भी है
Huh?
वैसे. वो था कि प्रोजेक्टर ऑपरेटर को किसकिट में प्रोग्राम करना है. आई डोंट नो हाउ टू डू दैट.
Okay, so projector operator.
मतलब जो कंप्लीट सेट ऑफ स्टेट्स रहता है ना मल्टीप्लाई करने में वो वाला.
Hmm.
मतलब गेट टाइम्स बरा वो वाला.
Okay, ठीक है. Hmm. So just stop presenting.